An antioxidant found in the green tea plant could be key to tackling tuberculosis one day, and that's according to a team of international scientists led by Nanyang Technological University.
Researchers found that a compound called epigallocatechin, gallate, or EGCG, prevents the growth of the bacteria strain that causes tuberculosis by binding to an enzyme which provides energy for cellular activity.
The team has filed for a patent identifying EGCG as a possible treatment for tuberculosis.
And for more on this, we're joined in studio by the lead scientist of the study, Professor Gerhard Gruber from NTU's School of Biological Sciences. Professor Gruber, thank you for joining us.
Good evening, Steve. Good evening, Dawn.
So help us understand then, what prompted you to look into the compounds of green tea, of all things, with your research?
Yeah, let me try to understand it from the perspective of our research journey. So, first of all, we try to understand how the bacterium can generate ATP. And ATP is actually the currency of life. In all of us, we need that. It's like the battery, right, in a mobile phone. And important for us was to understand what that enzyme is doing, which is catalyzing this ATP. And we could see there are two motors which make up this enzyme. And in between the two motors, there are two proteins. And if one of these is altered, there's no production anymore of this ATP. And this has the consequence the bacterium cannot grow.
Okay, and then how did that lead you then to discovering that green tea was the answer?
So the point was we saw these wonderful insights and moved on then with the compound screening. And here we used more than 30 million of these compounds, and out of these, the green tea compound was effective. So it bound to this ATP synthase, as this enzyme is called, and in particular to this subunit which is in the middle and allows the communication to the two motors. And due to this, no formation of ATP can occur, no growth of the bacterium is possible.
Right. So in what form of this compound, in what form must it be in order to be effective? Could you simply drink green tea in order for it to have an effect, or does it have to be sort of catalyzed or used in a different way?
So there are studies described here, in particular also in Singapore, where it has been reported that there's a correlation of daily drinking tea to the reduction of the risk of active TB. But this needs much, much more studies to really validate this. So the point is that we actually like to take this compound from which we know where it is binding to and to optimize this even. So that means step by step to alter the atoms and to increase its binding affinity, and by increasing the binding affinity to increase the chance that it more potently can then inhibit the enzyme, and therefore cell growth is then also reduced.
And we know that there are already drugs to treat tuberculosis, so how big of a game changer is this discovery?
Yeah, so first of all, we have to see there are drugs which one calls first-line drugs, and these are about 5 of these. The problems which are arising here is that the success rate is quite low, means about 70%, which is a quite high number. Secondly, the effect is it does need a long treatment of more than 6 months. And this is the most important concern at the moment, is multi-drug resistance of these compounds. And this, of course, has a consequence, because one needs a second line of drugs which are there, but these are more toxic. So what we need now is a totally new set of compounds which have also a totally different mode of action. And that is important to try forward. And here, the green tea compound can be an important player, because it's a natural product, and if we have then in the near future the chance to optimize it, it will be a part of a future cocktail to do so.
And are we close to being able to optimize it? How soon could we possibly see it being used to tackle tuberculosis in a practical manner in patients?
I guess it's a very long journey and very difficult to predict. So what we try to do at the moment is to, as I said, to optimize it. And as you mentioned, this has been, the mechanism of action has been patented. And in parallel to this, we in our consortium have even identified more compounds and have patented this. So what is of interest from our side now is to see in which synergistic way the green tea compound with the other identified compounds can improve potency. And in particular, when we think then about multi-drug resistance, which is the big problem worldwide, right? So that we can then tackle this and to make also the treatment time much shorter.
So all the best with your continuing research on this, Professor Gruber. Thank you for coming into the studios as well. We've been speaking there to Professor Gerhard Gruber from NTU's School of Biological Sciences.